In this podcast, we're going to talk about intermolecular forces. This is the forces of attraction between two different molecules. They are not the attraction within a molecule. Those are called intramolecular forces. Intramolecular forces are like covalent bonds and ionic bonds. These are between two different molecules. The first type of intermolecular force is something we call London dispersion forces, also known more commonly as just dispersion forces. This is when a temporary dipole is formed by electron repulsion. A dipole is when a molecule has two different ends, one being negative and one being positive. So this is formed when the molecule has a temporary negative side and a temporary positive side. And I'm going to show you how this can occur. Imagine we have one molecule in the center of your screen here made up of three different atoms. And those atoms have their valence electrons circling within that molecule, around those atoms. And they will sometimes, the one on the left will have the electrons temporarily be on the right side. That causes the repulsion of the electrons within the middle atom of that molecule to also be pushed to the right. And that in turn will cause the middle electrons that are pushed to the right to push the right atom's electrons to be pushed to the right. Because all the electrons are found on the right side and they're negative, it gives this molecule a slight negative charge on the right side, and since they're absent on the left side, it gives it a slight positive charge on the left side. This is temporary for one moment in time, but can become a factor when we're talking about repulsion and attraction. So imagine we had two of these molecules, each having a slightly positive and slightly negative side. You can see that the positive side will be attracted to the negative side of two different molecules, leading to what we call a dispersion force. This will cause them to be attracted to each other for an instant in time and is very weak. But you can imagine if we have more electrons in that molecule, we're going to have a stronger dispersion force, a more likely chance of having a more negative and more positive side of each individual molecule. Having a few electrons in there, not going to be much of a force, but having a lot of electrons in there, a large force. So the larger the molar mass, most likely the more electrons it's going to have. That will lead to a stronger dispersion force. The second type of intermolecular force is called a dipole-dipole force. The force between the positive end of one polar molecule and the negative end of another polar molecule leads to this force. So if I have a polar molecule which has a not a temporary negative and positive charge, but a permanent negative and positive charge on it, they can be attracted to another molecule. The example we're going to use is hydrogen chloride here. Chlorine's electronegativity is much higher than hydrogen's electronegativity, giving it a permanent slight negative charge on the right side and a slight positive charge on the left side. When I take two of these hydrogen chloride molecules and bring them next to each other, the positive side is attracted to the negative side and it creates an intermolecular bond. And that's where they are attracted to each other. Keep in mind that this molecule also has dispersion forces as well. So this has dispersion forces and dipole-dipole forces, making it a stronger intermolecular bond. The third type of intermolecular force is called hydrogen bonding. It's a specific type of dipole-dipole formed when hydrogen is bonded to oxygen, nitrogen, or fluorine. That's the only three atoms that the hydrogen must be bonded to be considered a hydrogen bond. This is the strongest of all the intermolecular forces and accompanies dispersion forces as well. The classic example that's used for hydrogen bonding is water. You'll notice that the hydrogen is bonded to an oxygen here, and when it comes next to another water molecule, the hydrogen of one molecule is attracted to the oxygen of another molecule, creating that hydrogen bond. This is the strongest of bonds and can lead to things such as high boiling points or high melting points, low vaporization, anything like that. So let's go through a few examples of intermolecular forces and see if we can figure out the types that are in these three different molecules. The first one over there on the left is methane, and the first thing I notice about that one is that it's nonpolar. It is not a polar molecule, so there is no dipole-dipole or hydrogen bonding. The only type of intermolecular forces that would be involved if another methane molecule came close to that methane molecule would be dispersion forces. So because it's nonpolar, it would only have dispersion forces, a very weak attraction. So if two methane molecules came next to each other, they would probably bounce right off, leading itself to the behavior of a gas. Also, in that methane, it is very, very light. So even the dispersion forces are still very weak. Remember that dispersion forces only get stronger with the more molar mass or more electrons. The second one is methanol. And you'll notice that this is now no longer nonpolar, it is a polar molecule. And that hydrogen is bonded to an oxygen. That's one of our three atoms that leads to hydrogen bonding. So this is a polar molecule, and it has dispersion forces, of course, as you notice they all do, and it has what we call hydrogen bonding. So that would be a very strong intermolecular force. If one methanol molecule came next to another methanol molecule, there would be a strong attraction between the two molecules. The third example is also a polar molecule, and that oxygen there is bonded to a carbon. It is not bonded to that hydrogen. So this would lead itself to a polar molecule, and if another polar molecule like that one came next to it, it would be attracted. It is a polar molecule, it has dispersion forces, of course, and it is a dipole-dipole situation. Notice it's not a hydrogen bonding situation because the oxygen is not bonded to a hydrogen. Intermolecular forces can be used to describe phase changes, the forming, loosening, or breaking of intermolecular forces. The three on the left side of this table require energy to loosen or to break intermolecular forces: melting, evaporation, boiling, or sublimation. Notice all of those are going from a tightly packed intermolecular forces to loosely packed or even breaking of intermolecular forces. The ones on the right are releasing energy, and because energy is released from the particles, they're slowing down. That allows them to get closer together and form intermolecular forces. For example, if you take a liquid and release some of its energy, the particles slow down and it leads itself more to forming a solid, which is what we call freezing. Sometimes we look at phase changes through something called a phase diagram. This is a way to show phase changes with respect for pressure and temperature. If you study this graph, you'll notice that it's water, and at 1 atmosphere of pressure, at 0 degrees Celsius is the transition between melting and freezing. If you look at 100 degrees Celsius, you'll notice that is the transition from a liquid to a gas, or vaporization, or condensation. In order to sublime ice, we have to lower the pressure quite a bit in order to get it to skip the liquid phase and go straight from a solid to a gas. You'll also notice that there is a point on this graph where all three phases coexist. And that is what we call the triple point, down there at 4.58 torr of atmosphere and about 0.0098 degrees Celsius.